Okay, so let's get started, guys. So let's talk about the Pythagorean Theorem. So if I have a right triangle, and I know that this triangle is a right triangle because it has that little 90-degree mark right there, then I can say some things about this triangle. First of all, let's label the sides. Let me change this real quick. This side has a length of 1, 2, 3, 4. Well, that didn't work very well, did it? That's better. This side has a length of 1, 2, 3, 4. So if this side has a length of 4, what's the area of this square? It has an area of 16 with a side length of 4. What about this leg? Let's change it to green. This leg has a side length of what? 3. So what's going to be the area of this square? 9. Write it down, please. So the Pythagorean theorem says that if I have one leg of a right triangle and another leg of a right triangle, the sum of the squares of those legs will equal the third side, or the hypotenuse. So I can't really figure out, well, let's do this on the side and see what happens here. 16 plus 9 equals what? What's 16 plus 9? 25. So this area of this square should be 25. Well, I can't really figure out 5 from this side, correct? So let's make a triangle, a square on the side over here. That's a 5 by 5. 1, 2, 3, 4, 5. Is that a 5 by 5? So if I were to take this, I should be able to turn it, and it should fit right along the side of this, which it does. And that's where we get the whole a squared plus b squared equals c squared. When in fact, 4 squared plus 3 squared equals or I should say 5 squared. Okay, so you've seen it before. We've talked about it. We're going to put it into action. Questions so far? All right, why don't we put this into our own words? What is the Pythagorean theorem? What is its converse? And what are Pythagorean triples? So start with Pythagorean theorem. Put that into your own words, and then we'll talk about its converse. So we were talking about area. We were talking about the side. So what about the sum of the area of the legs will equal, well, no, we're talking about the area of the legs. That is squaring them, right? The area, this is an area. The side is just the side. But when I square that side, that's how I get the area of the leg. Squaring it is the area. Okay, so the sum of the area of the legs will equal the area of what? The hypotenuse. So what would the converse be? If I tell you you have a right triangle, you tell me what?
The long side.
You tell me. Well, Mrs. Muller, did you know that you can sum up the area of the legs and that will equal the area of the hypotenuse? What would be the converse of that statement? The converse of that statement would be if the sum of the legs equals the area of the hypotenuse, then what? Then it means it's a right triangle. See how that works? So the sum of the area of the legs equals the area of the hypotenuse. The sum of the area, thank you, of the legs equals the area of the hypotenuse, comma, then it is a right triangle. What's a Pythagorean triple? Remember the numbers I put up on the board? We just had one. Isn't that a Pythagorean triple? 3, 4, 5? So Pythagorean triples can be, the most basic is 3, 4, 5. What would be the next? You're close. 3, 4, 5. The next one would be multiply each of these by 2. 6, 8, 10. Multiply the basic one by 3. What will be the next one? 9, 12, 15. What will be the next one? 12, 16, 20. No, I'm multiplying each time. I'm multiplying 3 times 2, 4 times 2, 5 times 2. Then I did 3 times 3, 4 times 3, right? This is multiplying by 2s. This is multiplying by 3s. This is multiplying by 4. Okay, so Pythagorean triples, it has to be 2 different things. First of all, it has to make up, the sums have to be the hypotenuse, right? The sum of the squares have to be the square of the hypotenuse. And it has to be, there has to be a right triangle, and the sides have to be whole numbers. And you'll see in a second. It doesn't have to be a whole number for it to be a right triangle. In fact, oftentimes, which we'll learn in special triangles, they're not whole numbers. We're dealing with radical signs. Can we move on? Okay, lots of writing. Don't freak out. You don't have to write all of this down. Let's just read it together. Let's make sense of it. First of all, I'm going to say, okay, I've got a triangle. We're probably talking about a right triangle, correct? So let's draw one. No, I don't want it to be filled. Let's draw it like they have it. All right, so Carson City, Nevada is located at about 100 degrees longitude. So longitude and latitude, which way is longitude?
Long way.
Up and down, so that would be the y-axis. Okay. So at 120 and 39 degrees latitude, so 39, comma 120. Does everybody see how I did that? Okay. NASA Ames is located at 122 degrees longitude and 37 degrees latitude. So I'm going to label that 37, comma 122. No, don't worry about it yet. Use the lines of longitude and latitude to find the degree distance to the nearest tenth of a degree if you were to travel directly from NASA to Carson City. So I'm traveling from here to here, so I am going to be measuring C. Now I can find that by just measuring each side of this right triangle, correct? So how far did I have to go? Let's talk about longitude. So from NASA, if I was over here in the corner, how far would I have to go up to get to Carson City? Everybody see that? From 122 to 120, I have to go 2. Everybody see that? What about going from here all the way over here on latitude? 37 to 39 is 3? No, not looks. It says 37 and it says 39. So how far do I go from 37 to 39? 2. Right? It's not. It looks almost like 3, but we're going by the numbers they actually gave us. So the picture is not drawn to scale, obviously. Correct? So we're right there wrong. Okay, let's get to work. So this square is how much? 4. And this square is how much? So the sum of the squares should equal the square of the hypotenuse, right? So how much is 4 plus 4? 8. So if the area of the larger square is 8, how do I find the side of it? The square root of 8. Okay, when I find square roots, guys, I really like to estimate.
2.8.
Is that what it is? 2 and 8 tenths? What square do I have that's below 8?
4.
4. And what square do I have that's above? 9. And the square root of 4 is 2. And the square root of 9 is 3. Is 2.8 closer to 9? Yes. Correct? So does that answer reasonable? 2.8? Yes. So the distance is 2 and 8 tenths. Okay, moving on. All right, find D, so write this one down. All right, so I'm going to do the formula side by side as requested. Let's grab onto everything I have here and group it. Bring it over here, make it smaller. Everybody's got these numbers, right? So I could make it smaller. Okay, so this time we have the area of this square is what? 9. The area of the larger square is how do I find the area of the smaller square? I have to subtract, right? If this square and this square, the sum of these two squares makes this one, then wouldn't I subtract to find out what this one is? So the formula actually has, so in here I would just say 36 minus 9 is how much? 27. What's the square root of 27? Does that make sense? Yep. Does that make sense? Because 6 has to be the longest side, right? Okay, here's the formula. A squared plus b squared equals c squared. We know that a squared is, this side is 3 squared. Yes, as long as your hypotenuse stays on this side of the equal sign. And what c squared is 6 squared, so we get 9 plus, I mean, we're doing the same thing I was doing, right? Then I subtracted 9 from both sides. B squared equals 27, the square root of b. It is a lot more work, and when you're doing it this way, you can't see whether or not you're doing it correctly. You're just plugging in and hoping that you're getting the right answer. When you're doing it this way, you can actually visualize. The reason I teach you this way, guys, is because the number one, what do you think the number one error is on these Pythagorean theorem problems? They're adding the two squares instead of subtracting. But if you see it, you can see this is the bigger square, right? So if I know the bigger square, I know I have to subtract to get the smaller square. If I know the two smaller squares, I know I have to add to make the bigger square. If you can actually see it, then you can understand that. Yes, it is always C. The hypotenuse is always C. All right, a little bit different. I'll let you guys write this down for a second. Okay, so this one says verify that triangle ABC is a right triangle. So this is kind of like that converse statement, right? So in order to figure out that it's a right triangle, I need to know that a squared plus b squared equals c squared, correct? So let's label these sides. Let's look at, I'm just going to find the distances first. Let's find the distance from A to B first. You are more than welcome to use the distance formula or just use Pythagorean Theorem. How far do I have to rise? Up 2. How far do I have to run? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 100 plus 4 is 104. Does everybody see what I was doing? When I rise up 2, I'm finding this is the square. Actually, let me change it. This is the square over here, right? This is the square over here. Only it's a rectangle, but it should look like a square. Correct? And summing those up gives me the distance here. Okay, let's change my color and do the other side. From A to C, how far do I have to go to get from A to C? 1, 2, 3, 4. From here to here, I have to go 4. And to go over to C, 1, 2, 3, 4, 5, 6. Makes what? 52. And lastly, BC. How far do I have to go up to get to B? Let's do our run first. 1, 2, 3, 4. And my rise, 1, 2, 3, 4, 5, 6. Nope. It doesn't matter, but I'm doing it this way for a very specific reason. I just now figured out the distances. What else did I figure out? The areas. What else? I also just found slope, guys. What's the slope of this line? Or 1/5. Up 1 over 5, right? Yeah. Up 1 over 5, up 1 over 5. What's the slope of this line here? 2/3. What's the slope of this one? 3/2. right? All those things are all related. Okay, so how do I figure out, first of all, which one's the longest one?
AB.
AB, so that's C. It doesn't matter which one, because of a commutative property. This could be A, this could be B. So if I square, I should be able to add these two, and they should equal that one, right? So I should be able to square A plus B should equal C, correct? A square root and a square cancel each other out. Is 52 plus 52 104? So is this a Pythagorean triangle? Is it a triple? It is not a triple. Why? Because these are not whole numbers, right? This side is the square root of 52. This side is the square root of 52. And this side is the square root of 104. Questions? Pretty easy, right? This is the hardest part right here.
So it's yes?
Yes and no. Yes, this is a right triangle. The triangle, the 90-degree angle will be right here, because the 90-degree angle is always pointing at C, correct? Good job, guys. Yeah, you have 3 minutes. I just want you to sit there quietly while I finish this up. So determine whether 9, 12, 15 are the sides of a right triangle. You should know this one right from the beginning. It's a Pythagorean triple, right? Because 9 squared plus 12 squared equals 15 squared, which is 81 plus 144. I need you guys to quiet down. Does 81 plus 144 equal 225? Yes, it does. So the answer to this, guys, would be two different things. It asked if it was a right triangle. Is it a right triangle? Yes. Is it a Pythagorean triple? Yes. Here's the last one. Do we know if this is a triple? It can't be a triple because it's not whole numbers, but let's see if it's a Pythagorean right triangle. Which one's the longest side? 8. So it would be 8 squared equals 4 root 3 squared plus 4 squared. 64 equals, this is 4 squared would be 16. Root 3 squared would just be 3, right? See how I did that? I distributed the square to everything in here. 64 equals 16 times 3. What's 16 times 3? Is 48 plus 16 64? Yes. So yes, but not a triple. Okay, thank you.
Want me to leave it there or you want me to put it behind?